Microcomputers are compact, low-cost computers designed for specific lightweight tasks, such as running home automation scripts, controlling small robots, collecting sensor data, and hosting simple web dashboards. A typical board, such as a Raspberry Pi 5, processes data at around 5 to 10 times slower than a normal desktop PC, with 8 to 32 gigabytes per second memory bandwidth and 5 to 12 watts of power usage. They are used for IoT devices, DIY robotics, digital signage, small local servers, and classroom programming projects. Home computers are personal machines built for everyday tasks such as browsing, typing, school software, video playback, and light gaming. They usually include a mid-range CPU, like an Intel Core i3 or AMD Ryzen 3, 8 to 16 gigabytes RAM, and a 256 to 512 gigabytes SSD. Graphics are typically integrated, and cooling is basic with 1 or 2 fans. Performance is moderate. They run 3 to 6 times slower than a modern desktop PC, with 40 to 80 gigabytes per second memory bandwidth and 50 to 150 watts of power usage. This is enough for multitasking, streaming, and basic productivity. Home computers are used for homework, entertainment, online communication, simple programming, and general household computing. Desktop PCs are versatile computers built for productivity, gaming, editing, and professional workloads. They typically use CPUs like Intel Core i5, i7, or AMD Ryzen 5 or 7, 16 to 64 gigabytes RAM, and fast 1 terabyte NVMe SSDs. Many include dedicated GPUs, such as NVIDIA RTX or AMD Radeon, and cooling systems with multiple fans or liquid cooling. Performance is strong. Desktops deliver 300 to 900 gigabytes per second memory bandwidth when paired with a capable GPU and use 200 to 600 watts depending on load. They handle large files, high-resolution displays, and demanding software smoothly. Desktops are used for office work, gaming, video editing, coding, streaming, and any task that benefits from upgradable hardware. Workstations are high-performance computers built for professional tasks such as 3D modeling, engineering simulations, scientific analysis, and film production. They use CPUs like Intel Xeon or AMD Threadripper, 32 to 256 gigabytes ECC RAM, multiple NVMe SSDs, and professional GPUs such as NVIDIA Quadro or AMD Radeon Pro. Hey, I know it is a lot, but stay with me, okay?
Oh shit. Here we go again.
Cooling systems are heavy-duty, and power supplies range from 800 to 1,200 watts. Performance is significantly higher than consumer desktops. Workstations deliver 600 to 1,200 gigabytes per second memory bandwidth and maintain stability during long, intensive workloads. Workstations are used in animation studios, engineering firms, research labs, medical imaging, and any environment requiring precision and reliability. Gaming PCs are performance-focused computers built to run modern games smoothly at high resolutions and frame rates. Their functionality includes gaming, streaming, video editing, and running graphics-heavy applications. They typically use CPUs like Intel Core i5, i7, or AMD Ryzen 5 or 7, 16 to 32 gigabytes RAM, and fast 1 terabyte NVMe SSDs. A dedicated GPU, such as an NVIDIA RTX or AMD Radeon, is the main component, providing strong graphics performance. Cooling systems often include multiple fans or liquid cooling to maintain stable temperatures during long gaming sessions. Performance is high. Gaming PCs handle demanding games, support high refresh rate monitors, and run complex applications without slowdown. Memory bandwidth usually sits between 400 to 1,000 gigabytes per second, depending on the GPU. And power usage ranges from 300 to 700 watts. Gaming PCs are used for gaming, streaming, video editing, 3D work. Servers are computers made to handle many people at the same time. Instead of one person using it like a normal PC, a server responds to thousands of people who are all trying to use an app, a website, or a service. They use stronger processors like Intel Xeon or AMD EPYC. More memory, 32 to 256 gigabytes RAM, and fast storage, NVMe or enterprise SSDs, because they need to load information quickly for lots of users. They also move data very fast, 200 to 600 gigabytes per second memory bandwidth, and usually use 300 to 1,000 watts of power depending on how big they are. A server's job is simple. You open YouTube and tap a video. A server receives your request, checks your account, finds the video, and starts sending the video to your phone, while doing the same thing for millions of other people at the same time. That's a server. Mainframes are large-scale computers designed for continuous, high-volume data processing. Their functionality includes handling banking transactions, airline reservations, government databases, and enterprise-level workloads. They use specialized processors, large memory pools, and hardware redundancy to ensure uninterrupted operation. Performance is extremely stable. A modern mainframe can process billions of transactions per day, with tens of terabytes per second of memory bandwidth. Power usage typically ranges from 5 to 20 kilowatts, depending on configuration. Mainframes are used in environments where downtime is unacceptable and massive parallel workloads must run 24/7. Supercomputers are extremely powerful machines built for scientific and mathematical workloads. Their functionality includes climate modeling, physics simulations, medical research, and training large-scale AI models. They use thousands of processors connected through high-speed networks. Memory systems are massive, with terabytes of RAM. Performance is extremely high. Supercomputers process enormous datasets and run complex simulations that normal computers cannot complete in reasonable time. Memory bandwidth often exceeds 10,000 gigabytes per second across the system, and power usage ranges from 1 to 20 megawatts, depending on size. A normal computer thinks in clear choices. A bit is either 0 or 1, nothing in between. A quantum computer uses qubits, which can be 0, 1, or both at the same time. This both at once idea lets a quantum computer explore many possibilities in one step instead of checking them one by one. That's the basic difference. Normal computers pick one path. Quantum computers can look at multiple paths at the same time. But quantum computers today can only run tiny experiments, not real apps or real workloads. Building a real quantum computer is extremely hard because qubits are unbelievably fragile. They stop working if the temperature changes slightly, if there's vibration, if there's electrical noise, or even if a single atom bumps into them. To keep qubits alive, the machine must be colder than outer space and completely isolated from everything. This is why quantum computers today are huge, expensive lab machines that only work for seconds at a time. A fully stable, usable quantum computer is still far away. Distributed cloud systems are basically huge networks of computers spread across the world that work together as one big machine. Instead of everything running in one place, the cloud spreads the work across many data centers, so apps never slow down and storage never runs out. This is what keeps things like websites, mobile apps, AI tools, and streaming platforms running smoothly for millions of people at the same time. If only a few people are using an app, the cloud uses a small amount of power. If millions join at once, it automatically adds more servers and more processing power. Across all these locations, the cloud can move data extremely fast, reaching petabytes per second, and power usage can range from a few megawatts in small centers to over 100 megawatts in massive ones. If you like this video, make sure to watch my other videos. Okay?